So we are going to start taking a look at trig functions and what they look like when you sketch them. Okay, trig functions look very different than any other graph we've studied so far. Okay, let me show you an example of what they look like. Well, actually, before I even draw it, does anybody know what a sine or a cosine graph looks like? It's definitely not linear or parabola. It's nothing like those kind of things. Yeah? It's a wave, yeah. So that's the graph of sine. And you might notice the graph of cosine looks very similar. It's actually a horizontal shift. Okay. So that's what sine and cosine look like. They are the only two trig functions that are continuous, meaning you can draw them without ever lifting your pencil the whole time. If I show you what like tangent looks like, there's a pattern to it, and it's a repeating pattern, like sine and cosine, but you have to continually lift your pencil up. So tangent is not a nice wave. Okay? Neither is cotangent, secant, or cosine. Okay? Sine and cosine are the only two. But because all trig functions basically have a pattern that repeats over and over, they are called periodic. So any function, not just sine and cosine, those are the ones we're studying today, but all trig functions are periodic. Let me draw a little bit of the sine function for you again. That's what we call one section or one cycle of the function. When we do a sketch, that's pretty much all we do. Because if you can sketch one cycle of the function, you could sketch as many cycles as you want. You just have to copy and paste that one cycle over and over. So if you look at, let me get rid of tangent so we can see it a little better. If you look at sine and cosine, can anybody tell what the highest and the lowest that it looks like they go are?
1 and negative 1.
Yeah, the highest and the lowest they go is 1 and negative 1. So this is the one I did in blue. It's the first cycle of the blue one. It starts at 0, it goes to 1, 0, negative 1, and then those values are going to repeat. 0, 1, 0, negative 1, 0, 1, 0, negative 1, and then they keep repeating. 0, 1, 0, negative 1, 0, 1, 0, negative 1. And I can show you that just by copying and pasting that. I don't know if I did it. No, not even close. 1, 0, 1, 0. Right? So those y values keep repeating themselves over a given set of x values. Okay. What's the given set of x values? It's from here to here. That distance between those two red marks, that's the distance that you have to travel before the graph repeats itself. So the 0, 1, 0, negative 1, that pattern will keep repeating itself over that distance. Anybody have a guess how far that distance is? It's, yeah. It is 2 something if you measure it in radians. And it has to do with the amount of radians that are all the way in a full circle. Anybody remember how many radians in a full circle?
2 pi.
2 pi, yep. So if I set this window, let's put it in radians. If I set this window to start at 0 and stop at 2 pi, you will see exactly what's in that green box. it's drawing both of them. But if I just draw one of them, now you'll see what's in the green box. Up, down, back up. What if I wanted to see 2 full cycles? Instead of setting this to 2 pi, what do you think I could set my maximum to? 4 pi, yep. If I set it to 4 pi, I can see 2 full cycles. There's 1 and there's 2. That's 2 cycles. All right. How about if I wanted to see 3 cycles? So, yeah, I could set it to 6 pi. However many chunks of 2 pi you set your window to, that's how many cycles you will see. Okay. Now, what's 2 pi the same as in degrees? 360. So I'm in radians. If I change to degrees, I can do exactly the same thing. But if I want to see 1 cycle, I'd set it to 360. And now we're seeing 1 cycle. So a lot of times people will put in like 2 pi and they're accidentally in degrees. They hit graph and they're like, why doesn't it look like a wave? Well, it doesn't look like a wave because you're specifying a number in radians and your mode is in degrees. You can't mix them. So if you want to be in degrees, 1 full cycle is 360. A lot of times what we will do is zoom 7. Okay, zoom 7 is what we call, it's a zoom for trig functions. So it's like zoom 6, but it's what we use when we do trig. So if you do zoom 7, it usually will give you a pretty good window to look at your function. Okay, not always, but a lot of times it's a good starting point. Okay, so the length of that interval, the length of that cycle before the graph repeats itself is 360 degrees, or 2 pi radians. That's the length of the interval before the graph starts to repeat. So let's say that that wave represents our standard sine or cosine function. You can change that. Okay? You can change the amount of time it takes to repeat by doing something like this. Okay? Well, I didn't draw it very well. But now that graph, pretend it's straight, that graph is repeating a lot faster. Okay? I can take that and I can stretch it back out. And now the length of the wave is a lot longer. It's a lot slower. So we can change that number, but we're not going to get into changing that number right now. So 2 pi is the distance between 2 corresponding points in different cycles. Whether you look at from here to here, or you could look at from there to there, like the low point to the low point, the high point to the high point. The distance should be 2 pi. I've kind of been using these 2 words interchangeably. Period length, cycle length. They mean the same thing. That is 1 cycle of the sine function. It's 1 full period of the sine function. Where you see the word cycle used more, when you talk about like electricity. Electricity is measured in cycles, well, alternating current is measured in cycles per second, and that's hertz. So cycles per second is a measurement that's used with any kind of electricity that's alternating current. Okay, so any question on what a cycle is, or what a period is in the graph? And what's the length again of the standard sine and cosine period? 2 pi. That's the standard length. Yep. Okay, when we're graphing sine and cosine, and I kind of already alluded to that, you really need 5 points. You need the start value, the end value, so start and end, the middle, the high, and the low. If you can find those 5 points, you will get a pretty good sketch. And again, we are only going to sketch one cycle, because then if you want the second cycle, you could just literally copy and paste the first cycle again. It's the same thing. Okay, so I've labeled the 5 points. We know that it starts at 0, and we know the cycle ends at 2 pi. What's 2 pi again in degrees?
360.
That's the same as 360. I'll put the degree measurements down at the bottom. What's halfway between 0 and 360?
180.
So that's 180. What's halfway between 0 and 180?
90.
90. And what's halfway between 180 and 360? 270. So in degrees, each tick mark here represents how much?
90 degrees.
Yeah, they're each a jump of 90 degrees. In radians, they're each a jump of, what's 90 degrees in radians? Pi over 2. Yep. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, if you wrote it with a denominator of 2. So all of those points are spaced exactly 90 degrees apart. And that's why we pick them, because they're all spaced equally. Whenever you're making a graph, that's what you want. All right, so that's the 5 points that we need when we're making a sketch. So what I'm going to do is I'm basically going to give you the 5 starting coordinates for sine and the 5 starting coordinates for cosine. These are the 5 for sine. We're going to write them down in a table. But if you look at that graph in blue, that's the graph of sine. We're going to write down the coordinates of 1, 2, 3, 4, 5. They're the 5 points in the first cycle. Okay, so let's start with this one. Anybody think they can give me the coordinate of that first blue point? Yep.
0, 0.
0, 0. It goes right through the origin. Yep. Okay, so for sine, your first point is 0, 0. Okay, how about this second point? I think they can give me the coordinate for that one.
The 2, 1.
Yep, it's pi over 2, comma 1. We are going to do it in radians. So pi over 2, 1. There's your second one. Okay, third point is right here. What's the coordinate for the third point?
0.
Pi 0. Okay, let's do the fourth point while we're here.
3 pi over 2, negative 1.
3 pi over 2, negative 1. And the last point, 2 pi comma 0, gets you back to the beginning for the next cycle. So those are your 5, what I call the 5 starting coordinates for sine. Okay, now, if you look at cosine, let's put cosine up there. What did we say earlier? What's the difference between sine and cosine?
Cosine shifted.
Right, there's a shift of 1 tick mark. And does anybody remember how much is each tick mark worth? 90 degrees, exactly. So sine and cosine are horizontal shifts of each other by 90 degrees. So the red one starts right here. What's the first coordinate in the red graph?
0,
0, 1. Okay? So it's like all the y values have been shifted down. It's like in that table, it's like they've all moved like 1 unit. So we have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi back at what you started with for the next cycle. So those are the first 5 coordinates in the cosine cycle. Now, technically, cosine goes on forever. When I say the first cycle, I mean the first cycle that's positive.
Could you scroll back up just like that little text that you wrote up top before this? Yeah.
It's very important we get these tables right, because if we get the table wrong, or you copy it wrong, then every transformation you do will be based off an incorrect starting table. That means every problem will be wrong. So we really got to make sure that those 2 tables are copied correctly. And what we're going to do is we're really going to break down how we go through it. We're going to go through each transformation one at a time, very slowly. We normally do all 4 at the same time. Okay, we're going to start with just shifting left and right, then just shifting up and down, then just stretching up and down, and then just stretching left and right. And those 4 transformations, those are the first 2 days of lessons. So that's why I said we might be able to do them today. I don't know, we'll see. Okay, does everybody have the tables? Okay. Because we're going to do 1 transformation at a time, for now, when you're using those tables, 1 column will change and 1 column will stay the same, because you're only doing 1 transformation. You can't affect the x's and the y's with just 1 transformation. When we start doing multi-transformation problems, like shifting up and left at the same time, then no, this won't be true anymore. You could change the x's and the y's at the same time. But we definitely will not get to that. Okay. So everything that I just told you, that's pretty much the background information for all the sine and cosine stuff we're going to do this week. Now, the next 4 things, however many we get through, I'm going to go through each transformation one at a time, starting with shifting left and right. Okay. When you shift left and right, I know we normally call it a horizontal shift. And you can still call it a horizontal shift. It's just the word that you're going to see associated with it more often is a phase shift. Okay, so this is a program that lets me generate different sound frequencies, but one thing I can show you is what happens during a phase shift. So if you watch the graph, I'm doing a phase shift right now. You can see slowly, it almost looks like the lines start to get blurry at first. And then you can start to see the wave is actually shifting. Okay, so I can slide the wave left or right. Okay, so that's a phase shift, sliding left and right. That's all that happens. All right, and if we have a little time later, I can show you the effect on what that sounds like when you do that. The nice thing about the transformations is every transformation that we know is exactly the same for trig functions as it has been for every function we've done on here. When you do a shift, any kind of shift, what arithmetic is involved? Which operation? Is shifting when you do the add subtract, or is shifting when you multiply? Add or subtract. Where do you add or subtract? Is that on the inside or the outside? when it's a horizontal?
Inside.
Inside. Yep. So like if you do sine of x plus something or minus something inside your argument, okay, just like a log function. Think of it the same way. That would shift your graph 2 units. And does anybody remember which way plus would shift it?
Left.
Yes, it's backwards, to the left. So plus would shift to the left, minus would shift to the right. Okay, so that's the format. And then down below, I'm just describing what each direction does, which hopefully we already know. Now you can shift by any amount you want. Okay? You could shift it by, it's an amount of degrees or radians, but you could shift it by 10.3 degrees if you wanted to. The most common amounts that you're going to see a graph shifted by is 45 degrees, 90, and 180. Those are the common ones. Technically you can do anything, but those are the ones that we focus on. In radians, that a pi over 4 would be a 45 degree shift, pi over 2 is 90, and pi is 180. What do you think would happen if you shifted it 360 degrees?
We just come back to where the original is.
Right. If you shifted it 360, I can't do it from here, I'd have to go to my desk. But the wave would basically slide an entire cycle and it would line back up again. So shifting 360 degrees is essentially like shifting nothing if you're looking at the whole wave. I mean, yes, technically it moves, but you can't tell that it moved if you draw the entire wave. Okay, so any question on what plus and minus do? Also, the reason I'm using the letter A is because when you do multi-transformations, this is the very first one you do. So I'm going to use the same letter scheme that I've used all year, the A, B, C, D. Okay, so when you shift left and right, okay, think of like this coordinate here moving to there. What changes in the coordinate when it moves to the left or to the right? I guess what part of the coordinate is affected?
The X.
The X. That means the Y's are not affected. Okay, if all you're doing is shifting left and right, the Y values are unaffected. So you can look back at the original table that I gave you and copy the Y values down. So if the Y's are going to be staying the same, that means the X's are going to change. Okay, so let's think for a second about this one. X minus pi over 2. What way is that graph going to move? X minus pi over 2.
To the right.
It's going to move to the right. If you had a coordinate here and you want it to move there, what would you have to do to the X value to make it move to the right? No, if you subtract something from an X value, the X value is going to get smaller. So if you want to move it to the right, you need to add, you need to increase it. So this is supposed to move to the right, which means the X value needs to increase, which really means you need to add pi over 2. So a horizontal shift is always the opposite. Okay? You always do the opposite. If you see a minus pi over 2, you're going to add, and everything will move to the right. If you see a plus pi over 2, everything needs to move to the left. To move to the left, you need to make your x's smaller. That means you need to subtract something. Okay, so you always do the opposite. All right, so let's look at setting up our table, and then down below we'll do the sketch. Okay, on the test, the table is going to be worth most of the points. So it's very important we get this table correct. Okay, first, we have to identify that this is a horizontal shift. And we know that because we're subtracting inside the parentheses. Which column stays the same? The y's. Can somebody remind me for the sine function, what are my 5 starting y values?
0, -1,
And 0. Okay. Now I'm going to write down my 5 starting x values, but I'm not going to put them in the table. I'm going to put them off to the side. Okay. What are my 5 original x values for the sine function? Yep.
Starting with 0,
Mhm.
and it's 1.
They're all going to have pi in them now.
Oh, wait, pi over 2.
Pi over 2.
Pi. 3 pi over 2. 2 pi.
2 pi. Now, all of those need to be altered because we're shifting. Are we going to add or are we going to subtract? We're going to add. How much are we going to add to each one of them? Pi over 2. I'm going to shift them all to the right because that's the direction they should go in. Shift them to the right. When we do this, we didn't start with any decimals. So when we write our answers, we're not having decimals. Okay, we have to leave them as fractions with pi. So the first one, well, it's going to be pi over 2. What's pi over 2 plus pi over 2? Pi. That's 2 pi over 2, which is just pi. Now this one you need a common denominator. It's pi over 1 plus pi over 2. What's your common denominator there? 2. So you're going to multiply top and bottom by 2. What's 2 pi over 2 plus 1 pi over 2?
3 pi over 2.
3 pi over 2. How about 3 pi over 2 plus 1 pi over 2? 4 pi over 2, or 2 pi. And now, if you write everything with a denominator of 2, you should start to see a pattern. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. What do you think the last one is? 5 pi over 2. Once I see the pattern, I generally go with that. What would be the next one after 5 pi over 2 not reduced?
6 pi over 2.
Yep, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. That would be the next cycle. And then you would just repeat the 0, 1, 0, negative 1 pattern. Okay, so that's your table. The way I would grade that is you're going to get, like on the test, you'll have a blank table. There'll be 10 boxes in it. You'll type a number in each box. The pi symbol will come up for you automatically when you need it. And you'll get 1 point for each x and y value you get right. So that table would be 10 points on the test. Okay, now the sketch, that would be worth 2. All right, if you don't label a graph paper, what does each tick mark normally represent? 1. We don't want to go by ones because these are pretty awful numbers to go by ones. 1.57, 3.14, 4.7, 6.28. You're going to have to be estimating in between all these lines. So think about the values we started with. Were all those values equally spaced when we started? And we took values that were equally spaced and we shifted them all together. So are these new values equally spaced?
Yes.
Yeah. Then that's what I would use to label your axis. Use these new values because they're all equally spaced. And that's the only condition when you label your tick marks. You can't go like 1, 2, 5, 13, 74. You gotta keep the spacing equal, right? And we already have equal spacing with those x values. So I'm gonna do 0, pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. Now on the y's, I am going to go by ones. So you do not have to label what I'm doing right now. But if you want to, you can. And now plot your points. Pi over 2, 0. Pi, we're at 1. 2 pi over 2, 0. 2 pi, negative 1. 5 pi over 2, 0. And remember, this is a wave. So try to make it look curved. That's a little bit off. Fix that. That's better. Okay, so that one in blue, that is the new graph. If you want to compare it to the original, it would have been here, 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 and there. You don't have to draw the original, I'm just doing it for reference, so you can see it shifted to the right. And that is a phase shift by 90 degrees, or pi over 2 radians. Any question on the table or the sketch? So 10 points for the table, 2 points for the sketch. This whole thing is worth 12 points right there. All right. So that's a sine function shifted to the right. Let's try a different one. So now this is a cosine function. The only difference between sine and cosine is that starting table. All right. What kind of transformation is this? How about a little more general? Yeah, it's a horizontal shift. It's a phase shift. So we know that which column is going to stay the same? The y's. What are my y values for cosine? Here's where if we get the wrong table, we're going to get half the table wrong.
1, 0, negative 1, 0.
1, 0, negative 1, 0, 1. Yeah. Okay, off to the side, I will put my original x's. What are my original x's for cosine? Same as for sine.
0, pi over 2, pi, 3 pi over 2, and 2 pi.
3 pi over 2, 2 pi. And are we going to add? Well, I know you told me the direction is left. So does that mean we're going to add or subtract?
Subtract.
We're going to subtract. And what do we subtract from all of them? Pi. Okay, some of them we can do without common denominators because they already have it. Negative pi. Pi minus pi is 0. How about 2 pi take away 1 pi? Pi. Now, you could find the common denominators, or if you know that the points are equally spaced, and you know 2 of them, just find the one that's exactly in the middle. What's in the middle of 0 and pi? Pi over 2. If you found the common denominator, that's exactly what you'd get. What's in the middle of 0 and negative pi? Negative pi over 2. Anybody want me to do the common denominator to show you it's the same? 3 pi over 2, take away 2 pi over 2. That's 1 pi over 2. All right, so there's your table. Now, we started with 5 points that were equally spaced. We shifted them all by the same amount. Are the x's equally spaced in my new table?
Yes.
Yes. So use those x's as your labels. Okay. You're going to need 2 in the negative direction. So I would put negative pi there, then negative pi over 2. I don't know if you can tell, but the axis, it's supposed to look a little bit bolder than the other lines. That's 0. Pi over 2. And pi. And graph your points. So at negative pi, we're at 1. At negative pi over 2, we're at 0. 0, negative 1. Pi over 2, we are at 0. And pi, we are at 1. Okay, it looks kind of like it should be a V shape. But remember, what are we graphing? A wave. All right, so really, we're graphing that, and what you're sketching is that middle section. Okay, so what ends up happening is it's going to kind of curve down, curve up like that, and then if you were to keep going, you could continue the pattern. But that's basically what your sketch should look like. If I drew it a little bit better, you'd be able to tell that this part actually curves. It's like kind of curved that way. And then when it gets to this point, it switches and it curves that way. And then at this part, the curve switches again. So it's either curving like up or curving down. That's what these graphs look like. All right, any questions on that? All right, so that was a little bit bigger shift than the last one. That was a shift of pi, or 180. The first one was a shift of pi over 2. Now let's do a shift of pi over 4. All right, so which column stays the same? Y. And what are my Y's?
0, 1, 0, negative 1, 0.
Okay, and my original X's?
0, pi over 2, pi, 3 pi over 2, and 2 pi.
All right. Are we going to add or subtract to all of them?
Subtract.
And how much?
Pi over 4.
Subtract pi over 4. Okay. So the first one is going to be what?
Negative pi over 4.
Negative pi over 4. Now the second one, you don't have a common denominator. But hopefully once you do this one, you'll start to see a pattern. What's the common denominator?
Pi over 2. Negative pi over, right, it's 4.
4. So let's go times 2 and times 2. What's 2 pi over 4? Take away 1 pi over 4.
Pi over 4.
Pi over 4. Okay, we can do one more, but then I think you'll see what's going on. Common denominator, 4. What's 4 pi over 4? Take away 1 pi over 4. 3 pi over 4. And now, does anyone see the pattern for the next one?
Oh, 7 pi over, or wait, no, hold on.
5 pi over 4. And the last one? 7 pi over 4. So the number in front of pi is an odd numbers. So then it would be 9 pi over 4, 11, and so on. Now, the only thing that can be a little tricky is when you set up your labels. Think of the numbers in front of the pi. Negative 1, 1, 3, 5, 7. Let's say that I put negative 1 right there. There's 1. Where would 3 go? Like right next to it? Right, you have to skip. And the reason you have to skip is because the numbers in your table are skipping. You have a 3, a 5, and a 7. So that's going to be a 5, and then I need one more over here, That's going to be the 7. The fact that they all have a pi over 4 with them, that doesn't change anything. You still have to skip. That's the part people mess up. So negative, so I'll just put like dots on the one I'm using. This one, this one, this one, this one, that one. Any question why it skips? Okay, now it's just a matter of graphing your points. 0. Let's see, pi over 4, we are at 1. 3 pi over 4, we're back at 0. 5 pi over 4, negative 1. And 7 pi over 4 at 0. So that's a shift of 45 degrees. It's a small shift to the left. It's a pretty small shift. All right. Any question on that? All right. So shifting left and right, that's the harder. That's probably one of the hardest transformations, just because the arithmetic has all fractions with pi. Shifting up and down is much easier because the arithmetic only involves a 1, a negative 1, or a 0. Okay, so vertical shift, it's going to move the graph up or down. What kind of arithmetic are we going to see with a vertical shift? Is that adding and subtracting, or is that multiplying? Adding and subtracting. So it's adding and subtracting again. What's going to be the difference this time? It's going to be on the outside. Right? So it's going to be when you add or subtract a number on the end. Technically, you could add it on the beginning. That's still a shift up 3. It's the same thing. We usually put it on the end. Now, when we shift, positive is going to shift it which way? Up, and negative, down. So add is up, subtracting is down. So with a vertical shift, it is not backwards. Never has been. And as far as vertical shifts, I would say any number is a number you could use. You could shift it up 2, down 6.5. You can shift it any amount you want. All right, so now we're going to think about a point that's here, moving like that. What is going to be affected in the coordinate if you shift up or down? The y value. What is not affected? The x value. So that means the x values are all going to stay the same. So for every shift up and down, the x values are going to be 0, pi over 2, pi, 3 pi over 2, 2 pi. When we do multi-transformations, no, that's not true. They could change as well. But for now, they're going to stay the same. Okay, so if x's are staying the same, y's are going to change. To get the new y values, you either add or subtract from the old y value, d. Don't do the opposite of d. Don't do the opposite. We never have for a vertical shift. Okay. Not sure if I mentioned d, but the reason I use the letter d is because once we learn all 4 transformations, this would be the 4th one. Since we're going to be working with the original y values, we're going to be working with 0s, 1s, and negative 1s. Arithmetic, very easy. look at that one. We know it's a shift because there's addition. But how do we know whether it's the horizontal or the vertical? It's on the outside. Okay, sometimes people say, well, there's no parentheses. I could add parentheses and it's still a vertical shift. Those parentheses did nothing. They're not needed. Okay? You could put parentheses around that too. It's still a vertical shift. The only way it can be a horizontal shift is if you had parentheses exactly like that. Now it's a horizontal shift. But 2 would be kind of a weird amount to shift by horizontally. It's not a 45, 90, or 180. I'm not saying you won't see it, but it's not very common. Okay. Let's make our table. All right. We know it's shifting up and down. Which column is not affected? X. Then what are my x's from the original cosine table?
0, pi over 2, pi, 3 pi over 2.
Okay, and while we're there, let's grab the original y's too. We'll put them on the outside. Can you tell me what the original y's are too?
0, 1, 0, negative. I mean,
1, 0, -1, 0, 1.
Yeah. So the first ones you read were for the sine table. No. So even if you mix it up, I mean, you'd still get the points for x's because they are the same, but all the y's would end up being wrong. All right. Now we got to modify all those y's. What are we going to do to all of them? We're going to add 2. Okay, so my new y values will be
3, 2, 1, 2, 3.
3, 2, 1, 2, 3. Yep. And there's our table. So that's the cosine function shifted up 2. I am going to label here just so it's easier for me to see. I don't need to because I am going by 1s on the y, but I am not going by 1s on the x. So I need labels on the x-axis. 0, 3, 2, 1, 2, 3. There you go. And remember, that's the middle part of a wave. Okay. Any question on that one? I think we'll just do one more of the vertical shift and then probably just save the other 2 for tomorrow. All right, so sine of x minus 3. Ben, what's going to stay the same there? Yeah.
Sorry, the what's? The x's.
Yeah. And what are my original x's?
For sine. I didn't read out tables.
You don't have the table? No. Can anyone help him out? What's the table for the x's on sine?
0, pi over 2, pi, 3 pi over 2.
Okay, so I got those.
Those are the same.
What are my y's for sine? Just the original.
0, 1, 0, -1, and 0.
Yep. So we got all our y's. And now we need to do something to them. What are we going to do to all 5 of those?
Subtract 3.
We're going to subtract 3. Okay, so my final y values after shifting are
-3, -2, -3, -4, -3.
Yep. Okay, you'll know pretty clearly if you graph it and you make a mistake in the table, because, I mean, if you graph something and your point, your graph looks like that, then you must have gone the wrong way with your point or something, because it should make a wave. All right, so we've got, let's see, we'll mark this as 0. Go down to -4. I'm going to put my labels above the graph this time, because then they'll be out of the way. 0, pi over 2, pi, 2 pi over 2, 2 pi. All right, so 0, -3, -2, -3, -4, and -3. Perfect. And what do we call that again? That's one cycle or one period of the wave, which has a length of 2 pi units left to right. Okay, any questions on that? All right, so tomorrow we won't have any of that kind of beginning stuff to go over, but we'll have homework. So we might be able to we'll definitely do the stretching, but maybe we'll do the stretching and the multi-step transformations. Okay, so we'll see. All right, so graph and make table. Okay, so the homework is those 7 questions. For each one, I want you to make sure you make the table. So show me the 5 new coordinates and the sketch. Okay, you have to have both to get full credit.
That works.
Okay, and I'll make sure I put that up on YouTube as well.